Finding equations of lines with Adam Maths Tutor. Here are the beginner questions, some of the easier questions that you're likely to find on this topic. The equation of a straight line can be written in the form of y equals mx plus c, where m is the gradient of the line. This tells us the slope or how steep the line is, and c is the y-intercept, where the line crosses the y-axis. Y represents any y-coordinate of a point on the line, and likewise x represents any x-coordinate of a point that lies on the line. When the equation of the line is drawn graphically, as shown with these two questions, I can use the rise over run to find the gradient, picking 2 points that go through the corners of the squares to make it easier to count them, and drawing a horizontal with a vertical to create this right angle triangle. I can count to find my run. Starting from this point, be sure to count the numerical values of x rather than the number of squares. Notice how the scale for every 2 squares counts as 1, so these 2 squares to the right would actually be an increase in the x direction of 1. Since we're going in the positive x direction, I'll label this as positive 1, and my rise would be 1, 2, 3, 4. Each 1 increase in the positive y direction is represented by a square, so slightly different to the scale in the x direction. 4 over 1 is 4. And my y-intercept is the point where the line crosses the y-axis. I can see that it intersects at this point here, which is negative 4. Therefore, the equation of this line would be y equals 4x, take away 4. For the second question, again, I can find my gradient by looking at the rise over the run, picking 2 points that go through the corners of the squares, and drawing a right angle triangle to connect them. Starting from this point, I'm actually going down by 2, which would be a rise of negative 2, and then across by 1, 2, 3, 4. Remembering that each 1 increase in the x direction is represented by 2 squares, so this would be an increase of 2 in the x direction. Negative 2 over 2 is a gradient of negative 1. My y-intercept is positive 3, so therefore the equation of the line is y equals negative 1x plus 3, which can just be written as negative x plus 3. On to the intermediate questions with an increase in difficulty. A line with a gradient of 3 goes through the point 2, 5. Determine the equation of the line in the form y equals mx plus c. A reminder that m represents the gradient. Now we've been told that the gradient is 3, so replace m for 3 to give us y equals 3x plus c. To finish this question, we need to find the y-intercept plus c. Since the equation of the line algebraically describes any point that lies on that line, I can substitute a coordinate that I know lies on the line to eliminate x and y. They've given me a point 2, 5. Just be careful, we write coordinates with x first followed by y, whereas the equation of the line is written in the form where we have y first and then followed by x here. It's a common misconception to substitute these values the wrong way round. The y part of the coordinate is 5, and the x part of the coordinate is 2. So 5 equals 3 lots of 2 plus c. I can use this to solve and find c. 5 is equal to 6 plus c, and subtracting 6 from both sides will leave me with c, which is negative 1. For my final answer, I just need to rewrite the original equation, y equals 3x, but replace c for the value that's now been found, which is negative 1. Therefore my final answer is y equals 3x, take away 1. The second question is similar, but I have a negative fractional gradient, which often makes the calculations trickier. Y equals negative a half of x plus c. Substitute the x and y values of the known coordinate that lies on the line. The y value of the coordinate is 5, and the x value is 4. 5 equals negative a half of 4 plus c. 5 is equal to negative 2 plus c, and in this case I can find c by adding 2 to both sides. So c is equal to 7. Again, rewrite the original equation, but using my known value for the y-intercept. So my final answer is y equals negative a half of x plus 7. On to the advanced question, one of the trickier questions that you're likely to find on this topic. A line passes through, and 2 coordinates are given instead of the gradient. I need to determine the equation of the line in the form ax plus by plus c equals 0, which is different to y equals mx plus c, and a, b and c are integers. If the gradient is not known, and I've been provided with 2 points, I can use the formula y1 minus y2 over x1 minus x2 to help me find it. The difference between the y values will give me my change in y, which is the rise. It doesn't matter which point we start with, we should still end up with the same answer at the end as long as we stay consistent. So if we start with 3 and take away 2, then when I look at the x values to find my change in x, which is the run, I need to make sure that I start with the corresponding x value to the same y value that I started with. So 6 is paired with 3, take away 9, which was paired with 2. Simplifying, I get 1 over negative 3, which is a gradient of negative 1/3. Now I know the gradient, I can start by substituting into y equals m, which is negative 1/3, of x plus c. I need to substitute a point that lies on the line. Since the line passes through both of the coordinates that are given, I can use either of them. I'm just going to use the first one, 6, 3. The y value is 3, which is equal to negative 1/3 of the corresponding x value 6 plus c. Simplifying, 3 is equal to negative 1/3 of 6 would be negative 2 plus c, and then adding 2 to both sides to find c gives me a y-intercept of 5. Rewrite the original equation, y equals negative 1/3 of x plus 5, but include your y-intercept for c, y equals negative 1/3 of x plus 5. The question asks me to write in the form of ax plus by plus c equals 0, where a, b and c are integers. Since I have a negative 1/3 of x, this involves non-integers. I can eliminate the fraction by multiplying through by the denominator of the fraction. So timesing the whole equation through by 3y equals negative 1x plus 15. Since my equation is equal to 0, I can add 1x to both sides and take away 15 to make my equation equal to 0. An alternative answer, if we brought all of the terms over to the right hand side, we would have had 0 is equal to negative 1x plus 15 minus 3y. We can convert from one to the other by timesing through by negative 1. Notice how 3y is positive here, but negative here. 1x is positive here, but negative here. And 15 is negative here, but positive here. Both of these are correct and would get us full marks in the exam. Lastly, determine the coordinate of the point where the line crosses the x-axis. It might be easier to do this using my equation written in the form of y equals negative 1/3 x plus 5. When the line crosses the x-axis will be when y is equal to 0. So you can substitute this into the equation to give me 0 equals negative 1/3 of x plus 5. And now I can solve this to find my corresponding value for x. Adding 1/3 of x to both sides and multiplying by 3 gives me x equals 15. Therefore, the coordinate of the point where it crosses the x-axis would be when x is 15 and y is 0, 15, 0. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and let's see if you can spot what they are before writing some corrections in the comments below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.